Hi everyone, welcome to another episode of our tutorials on Circos for Bioinformatics. In this video, I'm going to show you how to identify sequence repeats and visualize them. Okay, we are going to use BLAST and Circos. So that's what we are going to generate at the end of the day. We will have a Circos plot, and then we will have the links. So the link represents repeats. So if let's say we have a link from this region to this region, that means that those regions are repeat sequences. That's basically what this means. All right, so that's what we are going to now. With this plot, we add something else, and that's the GC Skew. So at the end of the day, we are going to generate this final image here. So the outer circle represents the chromosome or the entire genome, and then the second chart, the green and orange represents GC Skew, and then the dark lines represent the length. So this is what we are going to generate at the end of this tutorial. I repeat, this is what we are going to generate at the end of this tutorial. So this is what we'll do. We are first going to install the tools we will use. We are going to use BLAST and then Circos. Okay, so BLAST will be used to identify the repeats, and then we'll use Circos to visualize the outputs. And then we are going to download the example data. We are using the sequence data, of course, and then we are going to perform blasts. Okay, so what we are going to do is to blast the sequence against itself. So this will also be an opportunity for me to introduce you to BLAST if you're a beginner. And then after blasting, we are going to get some outputs, and we are going to extract some information from the outputs. Right. So the information that we extract from the BLAST outputs, we will then visualize that using Circos. So basically, this is what we are going to do in this tutorial. So just stay tuned. So for this tutorial, you need to make sure that you have BLAST and Circos installed. These are the tools we will use. If you don't have them installed, don't worry, you can still install these tools using Conda or Mamba or Mamba. So you can just install Conda or Mamba or Mamba alone, and then use that to install BLAST and Circos. Preferably, I recommend you use Mamba or Mamba because those ones are faster when it comes to installing tools. So instructions for installing these tools can be found in the description box. So for BLAST, for Circos, and even for these package managers, Conda, Mamba, Mamba, I have to that show how to set up all these. So you can check the description, you'll find links to videos that will show you how to set up your PC. So that's what we are going to do today. So without further ado, let's get started. So I will start with this here. Let me just show this because this is the core of the stuff. So this is what we are going to do. Let's see, let me just display it here. So basically, everything that we are going to do, I have already prepared them into a script. So I have them here like this. So these are the commands basically. So I will take you through them. Some of them we don't need to generate. I've fully generated them already. So I'll just show you where to download them, and the rest you will just do it. That's basically what we are going to do. So I also have some links here. Let me just share. Yeah, not this one. This one is a previous video I made. I'll share those links as well. So there are links that you can also use to learn more about Circos. And so I will share all of them. But if you want the script here, you can check the description box. The download link to these scripts can be found. I repeat, if you want all these materials that you're having to type them, then you can check the description box. The download link to these files are all there. So use them to get the example scripts. But we are still going to go through them anyway because I need to explain how each of these commands work so that you can apply the knowledge to your respective data sets. So let's proceed. So I'll start here. So this video is based on this tutorial here. I think I have to show that. So this is where I got the idea from. So I saw this tutorial which did something similar. It's a Circos tutorial, but it also shows how to visualize sequence repeats. Okay, so I just looked at it and I said I'll try to reproduce this, and then that's why I have this video made. Okay, so take note of that. Here they use a different organism. I'm going to use a different organism. So the visualizations may differ a bit, but the principles are the same. That's what matters. Okay, so I'll leave the link to this page in the description box. So let's get started. So let's do this. Let's open the terminal and then start. We will need to first install the tools. So let me open the terminal. I think I'll open mine now and then start. Yeah, nice. Okay, so it's done. So again, if you have BLAST and Circos installed, that's fine. If you don't have them installed, then make sure you use Conda, Mamba, or Macoma. So for those who don't have Blast and then Circos, and you rather have Conda or Mamba or Macoma, I'll show you how to install these two. So let's look at it now. So here's how we are going to install Blast and Circos using Mamba or Conda. So we will say Conda create, that's if you are using Conda, but I prefer to use Mamba, so I'll say Mamba create, and I'll say -n. I'm first creating the environment. Okay, so if you're watching my videos, then creating an environment shouldn't be new. So Mamba create -n, I'll say sequence underscore repeat. Yeah, you can use any name. Okay, any name should be fine. Just any name. You can keep it simple. Okay, so Mamba create -n sequence repeat. That's the name that I'm going to use for the environment. But you can still shorten it. That's fine. So just pick a simple name. Anyway, let me just use a simple name because some beginners and they might be confused with all the long names. So I'll just keep it simple. Okay, so I'll just say repeat. This is going to be the name of my environment. But ideally, if you're going to create an environment, the name should reflect what you are doing. It's very, very important because you may want to come back to the environment later on. So if you have a name that describes what you did or what you are going to do, it becomes easier when you want to go back for that environment and maybe use the tools installed in that environment. So just make sure you get a hang of that. Okay, so I'm going to do this. I'll say Mamba create -n repeat. Actually, let me just use this one, that would be better. So I'll say sequence underscore repeat. Let me just use this way. That's better for me because it describes what I'm going to do. And then I'll specify channels. So I'll say that C, Bioconda, that C, Conda Forge, that C, defaults. So these are 3 channels. So I'm going to specify all of them like this. And then I'll specify the tools. So I have Blast, I have Circos. These are the tools I'm going to use. So this is how I'm going to install them. It's very simple and straightforward. I repeat, if you have Conda, then you have to change Mamba Conda or Micro Mamba. Okay, but I'm using Mamba. That is why I'm using this word here. But the procedure is basically the same. So let's hit the enter button and let's install the tools. So this will not take much time. So you just have to wait. You can also see Blast and Circles. These are the tools. So Mamba or Conda will look for them and then do what it has to do to get them installed. So let's wait for everything to get done for us. Okay, so now let's type Y to install the tools. So I'll type Y. Let me just type it again. Sometimes you type Y, you have to type it again, but most of the time it's once. So I'll type Y. Yeah, so now it should be done. Okay, so just confirm, type Y, hit the enter button, then everything will be installed. So we just have to wait for everything to get installed for us. Okay, installation has been done. So if you install using Conda or Mamba, then after everything has been done successfully, the instructions for activating the environment will be indicated for you. Okay, so activating means you want to use the tools. So when you activate, you have access to the tools. So for me, it says to activate this environment, use this command. So this is the command I will use to activate the environment. If you're using Conda, it's likely instead of Mamba, you find Mamba or Micro Mamba. So just make sure to use whatever has been displayed for you. So I'm now going to do this. I'm going to just type this. I'll clear the screen and then activate the environment. So I'll clear and I'll say Mamba activate sequence repeats. Okay, so we have activated the environment. So I'll just do some tests before we start. So I'll just say +n. Let's do this. I have it there. I'll also do, so say +n, that's just version. So this is for me. I'll also test Circos. I'll just say, yeah, I just type it as well, but I'll just do this rather. So Circos, that's just version. just to see what comes up. Yeah, so everything is fine. We can also say Circos models just to see some stuff here. So this will list the dependencies. So you should see that everything is okay. So you should see okay for all the per packages or per models. So now everything is looking fine. So we can start the exercise. So let's clear the screen and continue. All right. What we are going to do next is to download the example data. So I have a sequence that I'm going to use. So let's go check it out. All right, so we are going to use this sequence. So this is a whole genome sequence. So basically, we are going to find repeats in this particular sequence. All right, this is AGY99. Okay, the reference genome for Mycobacterium ostrons. So this data here, the original data can be found on the NCBI database. This is the page, and I'll leave the link to this page in the description box. But I just made a copy here just in case you are unable to download from NCBI. So you can download from here, and you can also download from here. We are using the FASTA file. So it's a single sequence, a whole genome sequence, by the way. So the link to this page is in the description box. I repeat, the link to this page is in the description box as well as this one. All right, so you can use any of them to download the data. So just make sure to download it. But I will download from here. I have it here. So to download, I'll just click. And when I click, I'll come to this. It says view raw. I also have something like this. So when I'm here, I'll come to raw. I'll right click and I'll go to copy link. To copy the link. Again, I'll right click and copy the link. But if you want to download using the browser, you have to click this download button here. That's what you have to click. But I will download the terminal, so I'll just do this. Right click and copy the link. And I'll go to the terminal. Then I'll download it. All right. But before I download, it's important that I create a working directory and then I cd into it. Okay, so I'll need to create a directory first. So this is how I'm going to do it. So I'll say make that Circos and then I'll cd into it. All right. It's always advisable you have a directory for every project that you do. All right. So I'm in the directory. So now I'm going to say wget, and then I'll paste the link there. I'll download this file. So that's how I'm downloading, but you can also download from the NCBI. So that's fine. What is important is to get the file. So I'll clear the screen. I'll do an ls to see the file. Now I'll put this file in another directory. Okay, so that's what I'm going to do. I'm going to create another directory and then I'll move this FASTA file into that directory. So I'm going to say make that. I'll say genome. Now move this file into it. So I'll say mvn AGY99.FASTA. I'll move it there. Nice. So if I do an ls, I'll see the new directory. If I ls into it, I'll see the file there, the FASTA file. So that is what we have now. Okay, so we can proceed. Okay. Now earlier on, I made mention that we are finding sequence repeats, and so the strategy that we are going to use is to blast the sequence against itself. Now, for beginners, I'll encourage you to read about BLAST. Okay, BLAST is a tool that is used to find. Find sequences that are similar. Okay, so if you have a sequence, you want to check if there's a similar sequence on the NCBI database, you can use the BLAST. Okay, but you can also search for sequences locally on your PC. Okay, so that's the BLAST. When you are blasting locally, that's the approach. You download everything and then you perform everything on your PC. But you can also do it on the website. But with this data, which is a whole genome, it's about 5.6 MB. It's long. So even if you do it online, the BLAST system will tell you to do it locally, probably. So that's why we are doing it locally as well. All right. So for beginners, I'll encourage you to read about BLAST, what it does, its importance. Probably I'll make a tutorial to explain in detail what BLAST is. But now let's proceed. So what we are going to do next is to do a local BLAST. Okay, so we need to create a database. So this is what we are going to do. Now we have our sequence. Okay, there's a whole genome sequence. Okay, so what we are going to do is to create a BLAST database using the sequence. Okay, so that's what we are going to do. We are going to generate a BLAST database on our local machine. We already have a data on our machine, so we generate a BLAST database. Now this is a nucleotide sequence. All right, so with BLAST, the database that you create, you need to specify. Okay, so I'll show you all that anyway, but just note that creating a BLAST database for protein sequence is different from creating a BLAST database for nucleotide sequence. But what we have here is a nucleotide sequence, so I'll show you how to do that. So again, let me go over. I now have my sequence data, which is nucleotide sequence. So I'm going to generate my BLAST database. So that's what I'm going to do. So to create a BLAST database, we say make BLAST DB. Okay. And then we say -in. And then we specify everything we need to specify. That's what we need to do. Okay. But I want us to do this first. I think it's important. I want us to assign this file here to a variable. So I'll first say FASTA file equals, and I'll say genome/agy99.fasta. I just want to assign this to a variable so that I can make reference to it. All right. So now I'll do this. I'll say make BLAST DB, and I'll say -in. Okay, -in, and then I'll say, I'll do this. I'm going to do this. I'll say $FASTA file, because that's the file I'm using. Okay, because I already assigned that variable. Okay, and then I'll do this. I'll type space, and after typing space, I'll specify some additional options. Okay, so I have it here. That's going to be -db type, that database type. I made mention of it. So there's nucleotide, so NUCL. So this is how we create a BLAST database, okay, locally on our machine. Okay, so we first need to get our file, ideally a FASTA file. Then we call make BLAST DB -in to specify the file, and then -db type we specify. Here it's nucleotide. So let's execute this command. Perfect. So once we do it, if everything is okay, and you see the statement here. Okay, so this tells you that everything has been done. So this comparatively a small genome. Okay, so it shouldn't take much time when you are generating the BLAST database. So now we have generated a BLAST database. Okay, so let's clear the screen. Or even if you don't need to clear, so if you do an ls into genome, let's do it this way. You are going to see additional files generated. Okay, so we have our file ag100.fasta and other files. These files have different extensions. So we have this, all of them are here. So these are the additional files that will be generated. I repeat, these are the additional files that will be generated when you create a BLAST database, okay, using the FASTA file. So now that we have everything here, we are ready to go. So we have successfully created our BLAST database locally on our machine. So let's proceed. Okay, now let's ls again. Let's ls into the genome directory. So we have our sequence, which is here. We have also generated the BLAST database. That is why we have these files here. Okay, so now we are going to perform a BLAST search. Okay, so BLAST will help us to identify regions that are similar. Okay, so here we are interested in finding sequence repeats. So that means we are going to BLAST the sequence against itself. All right, so when you BLAST the sequence against itself, you are able to find regions that are similar. And so that means that those sequences will be in the genome. Okay, there will be multiple copies of those sequences in the genome, hence they being sequence repeats. So there's the strategy for identifying the sequence repeats. Right, so that's what we are going to do. So we are ready to go. So we will do this. We are going to call BLAST. Okay, we are running BLAST locally. Okay, so there's also an opportunity for me to show you how to run BLAST locally. So if you want to do a BLAST search locally on your machine, you need to first have your BLAST database generated. You also need to have your sequence. Okay, And so we already have everything here. So we are going to blast. So this is what we'll do. So we'll use blast n because we are dealing with a nucleotide database, a nucleotide sequence. So I'll say blast n, and I'll say dash e value. I'll specify a threshold. I'll say dash e value 1e dash 10. So this is a threshold that I'm going to set, and I'll say dash db. Okay, now the dash db, remember we created $first a file. Okay, if you say echo $first a file, okay, this was the definition. Okay, so this is the database. You know, when we generated the blast database, this was the in. Okay, the first a file. So we are specifying the same first a file here as our database. So that's what we are using. Okay, so don't get confused. If you are confused, don't just specify the 4 parts to the sequence. Okay, but I'm shortening it. That is why I'm keeping it that way. Right. So let's do it this way. I'll just redo it again so that we can see what is happening. So I'll just do this. I'll just define it again for us to see. I'll just say plus db so that beginners can understand equals, because I use this first a file to generate the blast database. Okay, I'll just say genome slash AJY99.first-A. Okay, so there's the blast database name. Okay, all the other files, don't worry, blast will identify them automatically. Okay, so now we will now perform the blast. So I'll say blast n dash e value. Now I started it 1e dash 10. I'll say dash db, and I'll say $blast db. Okay, $blast db. That's what I'm going to specify. But I can also use $first a file because that is the name. So the principle here is that when we are generating the blast database, you specify the first a file, the 4 paths. So it's that 4 parts that you use as the blast db here. Okay, so that's what I'm using. So if you don't use the blast db, then you have to specify the 4 parts to the first a file that you use to generate the blast database. So that's the principle behind it. So either you use this, you define it somewhere here, and then use it, or you specify the 4 parts here. So any of them should work fine for you, and make sure they are all in the same directory. That's what you need to do. Okay, now we can proceed. So I have it done. Okay, now I'll say dash query. Okay, so the query here is also going to be the same first a file because we are blasting against itself. Okay, so this time I'll just do this. I'll just say $first a file. Okay, remember we had already defined it. We had already defined the first a file. Okay, but for those who are still confused, I'll still define it again for you so that you don't end up confused. So it's the same first a file. So I'll just say first a file equals genome slash AJY99.first-A. I think that will make things clear for you. Okay, so that's it. So this is it. Now I'm going to call blast again. So we have our blast database defined. We also have the query sequence, which is in this file. Okay, now we can proceed. So I'll redo it. So I'll just say blast n, and then I'll say dash e value 1e dash 10 dash db, and that'll be $blast db, and then dash query is going to be what? $first a file, and then dash out, that'll be the output file name. I'll say blast out.csv. Okay, that's it. And then I'll add something else. I'll say dash out fmt. That's the output format. Okay, that is 10. Because with blast, you can generate different output files. Okay, so this one is a CSV format, that's output format 10. But you can also generate other files as well, but it's what you want. I think I'll just reduce the size of the text a bit so that they are all in the same line. That will help some people as well, so that we are on the same page. I'll just make it 21 in C, and that one should be fine. Okay, so that's what we have, okay, as our blast command. Now we are going to add something else. That is the word size. So I'll say space dash word underscore size, and I'll say 600. Okay. Now the word size here is used to specify the minimum length that a sequence should have. Okay, so if let's say we have a sequence and we have found that the sequence, there are multiple copies of it, all right, we are only going to consider that sequence as a hit if that sequence has a length of 600, or let's say that sequence comprises of, let's say, 600 nucleotide bases. Okay, so that's the length of the sequence basically. Okay, so there's the minimum length of a sequence that we consider as a sequence repeat as a hit. That's what we have here. So it's dash word size. I think I'll try to see if I can reduce the size a bit. I'll reverse it back. Let's try this. I want it to be on the same line so that you see what is happening. Yeah, so perfect. So this is it. So we have blast n dash e value 1 e10. This is a threshold, by the way. And then we specify our database and then our query file. Okay, and then we also have out. That is the output file. And then the output format is 10. So the output format, you give numbers. So number 10 represents a CSV file. Okay, and we have word size, that is 600. Okay, that's the minimum length of the sequence that we consider as a hit, or we consider as being repeated. All right, so this is the final command that we use. Okay, so now we are going to execute this command and then get our output. So let's execute this command now. Okay, blasting has been done. So if we do an ls, we are going to find this file here. It's called blast underscore out.csv. Okay, so this is the file. So this is the output file. So let's even look at it. I'll just do a head blast underscore out.csv just to see it. So we have some stuff here. Okay. Now for beginners, this may be a bit confusing, so I think I'll show you this. Yeah, so I have this page that gives a brief description of the header so that we can understand it. I'll just open it here. Let's see. So let's take a look at the file. So it's a CSV file, so I can open it with a spreadsheet software like this. Okay. So if you open it, by default, this is how it is. But the headers here, there are 12 of them. Then each of the headers has a meaning. Okay, so you can take a look at this page. It describes it here. So query, sequence ID, subject, and we also have additional information here. Okay. So that's what we have. So for this tutorial, I'll consider everything here as a hit. So I'm going to use everything here. But with blast, you can also decide to set additional thresholds, which is something that is beyond the scope of this tutorial. But then I want us to look at the headers. Okay. So we have 12 headers. Okay, so for this tutorial, what we want, the header that we want, or the header that we want, are the first header, okay, the sequence ID, because basically the same. Okay, we are blasting it against itself. So we have query and subject, they are still the same sequence ID. So that is okay. So we will just use one of them because we have to extract the information. So we want the first one. Okay, that's fine. Okay, we also need the 7th one, which is the query starts and then query end. So 7 and 8, we need it, and we also need 9 and 10. Okay, so we have 7 and 8, 9 and 10. So 7, 8, 9, and 10 will help us to know the regions where those repeats are. Okay, let's take, for example, let's look at this, for example, 7 and 8. So 1, 2, 3, 4, 5, 6, 7. So 7 and 8. That's 7 and 8. We also have 9 and 10. Okay, now here, the first one here, It's also a hit because it's the same sequence. Okay, so we are going to ignore it, but we will look at the other ones as well. So here we have this and this. Let me just look at them here. We have query start query and then subject start subject end. Okay, so subject here refers to the reference sequence. Okay, but in this case, it's basically the same. So don't worry about the differences. So we are looking at regions where there are repeats. So basically, what this tells us is that this region and this region, from this position to this position, the sequence there is the same as the sequence in this position, this and then this. That's what you should take from this particular tool right here. So this and this, the sequence here is the same as this and this. So this is a repeat. The same applies to this and this, this and this. They are the same. So it's also a repeat. Okay. So that is where the visualization comes in. So if you have it like this, it's going to be difficult to identify patterns. Okay, so this is where the visualization comes in. So we are going to extract some information from here and then use that to generate our Circos visualization. Okay, so that's what we are going to do. So we are going to extract the sequence ID. We will use the first one, that is header number 1. We are going to extract that's header, or let me just say column. Column will be appropriate. So we are extracting the sequence ID, that is column 1. Then we're also going to extract column 7 and then 8 and then 9 and then 10. Okay, that's what we are going to extract. Okay, so we are going to extract this so that we get what we call a Circos link, because we are going to represent them as a link. All right, so that's what we are going to do. So I'll explain a couple of things. Okay, but for now I want us to extract the needed information and then we can proceed. So let's get back to the terminal and then let's do this. Okay, now if you have a CSV file like this, you can easily extract the information from it using the awk tool in Bash on Linux. So that's what we are going to use. Okay, so that's what we will do. Let's clear the screen. This one, ls, and then proceed. So we are going to extract some information from it. Okay, so we will use awk. Okay, so that's what we will do. I'll say awk auk. I'll say -f. I'll bring a quotes, comma, quotes. That means I'm going to extract information from this file, but then the separator is a comma. That's what this simply means. Okay, because it's a CSV file, obviously. Then space, I bring another quotes, curly brackets, and I'll say print $1. That's column 1. Okay, and then I'll do this. I need to bring this here because we are going to separate them using a space. Okay, so this means that we are adding a space. All right, then I'll do this. I'll come to $7. Okay, again I bring a space. That's this, and $8. Okay, again I bring a space like this. So what you should note, let me just do it here. What you should note is that for every value we give, that is, let's say for $1, after we bring it, we bring a double quote and then a space and then another double quotes. Then we bring the next number, then double quote, space, double quotes. Okay, I'll show an example in the description box. And then we bring $8, double quote, space, double quotes, and then we say what? $1, double quote, space, double quotes, and then we will bring $9, double quote, space, double quotes, and then $10. So this is what we should have. Okay, so we have our values and then the space. Okay, and after that we bring our curly brackets, and then we bring our single quote. So this is what we should have, right? So we type our awk -f, we bring our separator, single quotes, curly brackets, prints, and then $value, double quote space, double quotes, $value. So that's how it should be. Okay, so that's how it should be. After that, we have to specify a file, but of course you can still download the example script to make your life easier, but you can still type it. I will leave a sample command also in the description box. Okay, so once you have specified this, then you need to also bring your file. We are extracting the information from blast out.csv. Okay, so that's going to be blast, let's call out.csv. So let's execute this command. Perfect. So we are going to see something like this. Okay, now I want us to just check something. Let's verify something here. Yeah, let's look at just the second one here. I want us to see this. I'll just compare just to make sure that I have everything I need. So I have my sequence ID. I have 5237245 up to 71, and then 15 up to 89. Okay, nice. So everything is done. Okay, so that's what we have. Now with what we have, I made mention that the first entry is the entire sequence. We don't need it. So we need to find a way to exclude that in bash, and bash can help us do this. Right. So let's clear the screen. Let's record a command, and let's add a pipe. And let's say tail -n space +2. Okay, so when you do this and you hit the enter button, everything will be specified with the exception of the first line. Let's just look at it. I think you'll be able to see it here. Yeah, so you can see that it's gone. So this is what we need. Let's clear the screen again. Let's record a command. Now with what we have, we will need to also save it to an output file. Okay, we need to save it to an output file. So for output file, if you are saving a test to an output file, of course, if you've watched my videos, you know the drill. So we bring up greater than symbol, and then you will say Circos_links.txt. So there's the output file. There's the name of the output file. For those who are confused, I'll just reduce the font size a bit so that we all see it's on the same line. Okay, I'll just do it this way. Let's see. Let's make it 19 probably. Yeah, this should be fine. Okay, so now you can see everything on the same line. So this is how it's supposed to be. Right, so we see something like this. Okay. So now you can execute the command. Okay, and then everything will be done for you. Now I'll increase the font size again, but before that, let's do an ls. You see the file here. Okay, but let me increase the font size and then we can continue. Okay, so this is the final file, okay, that we are going to use. So this is going to be an input to Circos. So we are gradually getting there. Of course, we can also take a look at the file. So let's take a look at it. This is it. Okay. You can also open it with a spreadsheet software. It's also fine. Let's just open it. Yeah, so this is it. You can see everything. So we have the sequence ID and then the regions that are repeats. So this is what we need. Okay. So we can close it. I think I had even opened this file earlier in a text file. So there's it. So that's fine. Okay. So we have what we need. Okay. That's for Circos. Now this is one of the input for Circos. But with Circos, we also need to generate what we call a karyotype. We also need to generate that. Okay. So we are going to generate a karyotype using our terminal. This is just one chromosome. So we will do it on a terminal. So we are going to say echo. I bring a double quote. I'll say CHR dash. I'll say CHR1. I'll say AJY99. That's the name. So if you've watched my videos on Circos, then you know the format for creating a karyotype. That's what I'm doing. I need to specify the genome size. So the genome size is 563.1605. Okay, so it's 5.6 MB basically. But I'll still leave this value in the description box. And then I'll give it a color. I'll say green. So there's the karyotype. So I'll save it to a file. So I'll just redirect it to a file. So I'll say karyotype.txt. If I do an ls, I'm going to find it. I can do a cut to display the karyotype. So this is what we have. It's a karyotype. I can also open it. So there's it. I think I also open it earlier on, but this is how it's going to be. This is a karyotype. So you have ch, then you define it, and that's it. So it's very, very simple and straightforward. All right. So we can proceed. Now, with Circos, we need to be consistent with the labels that we use. If you take a look at this one here, in this one, the output file here, the sequence names, okay, the labels, we use the accession IDs in the first file. But we need to change this. Okay, we need to change it to CHR1. Okay, so we need to change it. So to change it, we are going to have to replace every accession ID here with CHR1. So it's simple and straightforward. We are going to do this in bash as well. So what we are going to do is to say sed, and now say -i. So you can use sed to replace text, okay, in text files. So -i means that we are going to overwrite that text file. Okay, we don't want to save this to a different file. That's why I'm using -i. I bring a space and I'll bring a single quote. So I'll say s and I'll say slash. Okay, like this. Okay, slash like this, and I have to specify the ID. But let's just do this first. Let's just do a head -n1. Okay, and I'll just do Circos links here so that we can get this ID. That's what we need. Okay, so that's what I'm going to do. I'm going to replace all occurrences of this with this value here, okay, using sed. Okay, so I have my text file, this one is the contents. I have this also here, this text file, this is the content. But then with this text file here, I want to replace everything, all these accession IDs here with this, all the occurrences. So wherever you see this, we are going to replace with this one here. We are using the Linux utility called sed or scd. Okay, so to replace a text file, you say sed. Now say -i here means that we are going to overwrite the text file, this text file here. So we don't want to save the output to a different file, but we will keep it here. Okay, so I'll bring a single quote. I'll say s/, and then I'll have to specify what I'm going to change, which is this one here. I'll just do a copy and paste. And then I'll bring another one here, / and I'll say CHR1. This is what will be replacing that. /gen quotes. That's single quotes, and say Circos links.txt. And I'll execute this command. So now if I do a head -n1, for example, in this file, you see that everything has been changed. So we now have this here replacing. So that's what we need. So now we have all the input files for Circos. Okay, so let's do an ls. We have our karyotype. We also have our link file. This contains the information for the sequence repeats. So we are ready to go. So now we can start writing our Circos script. So let's proceed. So let's clear the screen. Let's do an ls once again. Okay, so I'll go over again. I have my Circos input karyotype and then the link file which contains information for the sequence repeats. All right. Now we need to define our ideogram. Okay, so I will start. I will say nano ideogram.conf. Okay, you can also use .txt. That's fine. Okay, any of them is fine. So ideogram.txt or conf. But for now, let's just keep them as .conf. You can use any text editor. right? I'll open it, I'll define my ideogram. So I'll start with this ideogram and I'll end /ideogram. Okay. And then in between, I'll give my configuration. So I'll start with the spacing. Spacing this, and then I'll say default equals 0u, break equals 0u. Now this one, I'm dealing with a single chromosome, so probably it may not be necessary, but I'm just defining them just in case. Okay, so that's for the spacing. Now let's look at thickness. And this one, I'll just put this here. So spacing may not be necessary because the single chromosome. Now thickness, you say thickness equals 20p. You can always change it. All right, let's correct it. We need to make sure the spelling is correct. So thickness 20p, and then stroke thickness is equals to 2. We need this also. Okay, now let's go to the next one. So ideogram border color, we also need to do this. Okay, so ideogram border color, I say stroke color equals green, and then fill equals yes. Some of these values you can change them, you can manipulate them. So you select those that you see fit. All right, now we need to add the radius information for the ideogram. So that's radius. Right, so now we'll add it. So I'll say radius equals, I'll say 0.85 r. So that's going to be the radius. All right, so that's how we do it. Okay, and then that'll be it. Okay, so this is it, and we should also make sure that we have closed the ideogram, okay, block. So we should have something like this. Now you can type Ctrl X and then save the changes. So we can do it like this. Okay, so we hit the enter button to save it finally. All right, so now if I do an ls, I'm going to find my ideogram.conf here. Okay, so that's how we do it. All right, now let's proceed. So let's do this. We are now going to generate our Circos configuration file. Okay, that will contain other information that Circos will use to generate our ideogram for us. We are now generating the ideogram. That's what we are generating first. So we have to open another file. So I'm going to say nano, and I'll say circos.conf to open it. So I'll start by saying include ideogram.conf. Then the next line, I'll say karyotype equals karyotype.txt. Then the next line, I'll define chromosomes. So I'll say chromosomes _ units equals 10,000. We need to make sure the spellings are also correct. I'll say chromosomes _ display default equals yes. I'll also need this. And then when I scroll down, image block, image, and then inside the block, I'll say include image.conf. I need this also. All right, that is done. Now I'll move to the next line, say include colors fonts patterns.conf. Then include housekeeping.conf. These ones come packaged with Circos, so we just have to specify them. Now I'll exit and save changes. And then if I do an ls, I should see my circos.conf file. So I am now going to run Circos and specify this configuration file. Okay, so I'll say Circos, say -conf, I'll say circos.conf. So let's execute this command. Perfect. So now Circos has completed its work. Okay, so we now have our ideogram. So let's clear the screen. Let's do an ls, and we are going to find some output files. So we have circos.png and then circos.svg. So let's take a look at the files. Okay, so I will move to the directory. This is it. I'll open it, and I'm going to see my file there. Okay, so this is the ideogram. It is the chromosome, right? So it's a single one, by the way. Okay, so we have it done. So now we are going to add the sequence repeat information. Okay, so it's links. So we are going to add that to it here. Okay, so this information here, Circos links, this one is what we are going to add. So we'll proceed with that as well. So let's get back here. So this is it. So to add it, we will use links. All right. So if you take a look at the Circos documentation, there is a section for links, which is this one here. I'll leave the link to this page also in the description box, so you can read more about links here, right? So we will add that to our configuration file, this one here. So I'll open it using nano again, and then I'll scroll down this side. So now I'll add this. I'm going to say links, and then I'll close it. And then inside it, I'll say link. This is a sublink, by the way. It's this link. Then I'll close this one. And then inside, I'll define my files or file as a single file. So I'll say file equals circos underscore links.txt. And then the radius is going to be 0.95R. And then color equals to black underscore A4. You can choose any color you want, that's fine. Okay, so choose any appropriate color. Now let's add something else. We need to add a curve information. So I'll say Bezier radius equals 0.1R. That's something you have to add. And then thickness equals 1. We also need that information. All right. And then we also need to add something else. That is Bezier radius purity equals 0.9. And then crest equals 0.5. Okay, something like this. So this is it. Let's make sure that we have closed everything. So there's a sublink, it should be closed. The links should also be closed. So we have it like this. So now we can exit and save changes. All right. Now I'm going to rerun Circos again. All right. So I'll say circos-conf. That'll be circos.conf. So let's execute this command. Perfect. So once we do this, we are going to have the links displayed for us. Okay, it will be done in the Circos plots. Okay, so we have it generated for us. So that is also done. So we can take a look at the outputs. Let's take a look at it. So let's take a look at it. This is it. We can open it and we are going to see our information here. So we have our ideogram representing the sequence, the chromosome, the genome, and then we have the length. So if let's say we have a line from this side to this side, that means that is what a sequence repeats. Okay, so this can let us know the sequence repeats that we have. Okay, so this can help you to visualize, and you can even know the areas where we have lots of repeats. Okay, so these are things you can do to visualize your data so that you can identify the patterns. Okay, so that's what we have. Now we will come back to this, but let's do something here. Okay, I want us to change something here. Let's clear the screen. Let's do an ls. Now with the karyotype, okay, let's do a nano into it. We can change the information in the karyotype as well. Okay, you know what we had initially was 5. Let me just reverse it. What we had initially was 5, but you can change it to 6, like this one here. Okay, so sometimes maybe you may realize that the number you gave for the sequence length, okay, you may want to change it. So it's possible to do that here. Okay, so previously we used 5, but then I've changed mine to 6. So I also want you to change it to 6. Okay, so that we are all on the same page. So please make sure to do that. So it's also a simple command, nano, and then you change it, and you can type Ctrl X and save the changes. So I want you to do that, and then you can proceed. Now let's get back to the figure, the plots here. Now what we have here, we can add additional information. So what I want us to do is to add the GC Skew to it. Okay, I earlier on even showed that, okay, in the image that I showed for the presentation. Okay, so we are going to add the GC Skew to it so that we can get some additional information. So that's what we are going to do. So let's get back here and do it. So with the GC Skew, I've already prepared the input file, so I want us to download it. It's also available on the GitHub repo. So let's download it now. Okay, so let's go to the GitHub repo again, the page where I showed the sequence, which is here. Okay, the link to this page is in the description box. So on this same repo, you'll find this file called gcskew.txt. So I want you to click it and then download it. So to download, click it, and then you'll be sent to this page. When you are here, you can click on this download button to download, or you can right click and copy the link, or you can also click the raw, and then you right click and copy this link here. Okay, so that's what I'm going to use. So I'll move to the terminal, and then I will download it. So I'll say wget, and I'll paste the link there. So let's download this file as well. Perfect, has been done. So let's do an ls. You'll see it's the GC Skew. Let's clear the screen. Let's do an ls again. Let's take a look at it here. All right, so this is it. So I can even open it. Yeah, so there's it. So there's this. Now the file here, I generated it using a Python script. Okay, so if you have your own sequence and you also want to generate the GC Skew, then you have to use the Python script. Let me even show you that first. Then continue. So let's take a look at it. Yeah, so this is the Python script. So I'll just open it here for you to see. So this is a script. So with this script, the only requirement is to have BioPython installed on the PC. Okay. And then when you want to run this on your own data sets, then you just have to change the path to the file. Okay, so for example, in our case, let me just clear this first. In our case, the path A file can be found in genome. So I'll just have to specify the path here. I have to define it. So I bring my single quotes or double quotes, any of them is fine. And I'll say genome /AJY99 first A. So this is it. Okay. And then the window, I'm using a 2 kilobyte window for the GC Skew. Okay, but you can also change it, but for now let's just leave it like this. So once you are done, there are commands also there here that will process and get to your final. So you can just rerun it. Just run the script. And once you run it, if everything is okay, you have this text, and it will also tell you the file name. So it's gcskew.txt. Okay, so that is what we just downloaded, this one here. So that's it. Now we are going to add a GC Skew to our Circos plots, right? So let's open Circos again. I mean the configuration file. So nanocircos.conf, and then let's proceed. So I'll just scroll down here. Yeah, after the next. So I'll add the information here. Okay, so let's proceed. So this is what we are going to do. So with the GC Skew is a plot, so we have to define a plot block, right? So I'll add that here. I'll say plots, and I'll close it. And then we are going to give our subplots. So plots, plots. Then in it, we will give our plots. So I'll start with this one here. So it's what file equals gc underscore skew txt. And then the type is equals to what? Line. And then radius is equals to 0.9r. So this radius, we want this to come before the sequence repeat information. That's the length. Now we'll specify something else. That is r0 equals 0.6r. Then r1 equals 0.2r. And then thickness, you say 6p. And then color, you say orange. So that's how we are going to do it. All right. It's very, very simple. Now let's change something here. Because we are adding the plots, we need to also modify the lengths. So here it was 0.95 for the radius for the lengths. And now we will change it to 0.8. So that's how we are going to do it. So let's change it here. So 0.8. These values you can always experiment. Okay, so if you see that the values you are given is not giving you what you want, you can always modify them. So for now, let's keep it this way. Okay, so that's about it. So we can exit and then save changes. Right, so let's make sure we have closed everything. Everything is okay. So plots. Okay. Now we see that here it's plots. It's supposed to be S. Okay. So let's just make sure we have corrected it. So make sure that the first plot that you have, this one here, make sure that it ends with plots. The spelling should be the same. Okay, the only difference is the slash. So that's for the first block, plots. Okay, make sure they are the same. Just compare and make sure they are the same. And then we go to the next. So that is plots, then plots. Okay, so sometimes you'll be typing and then there may be a typo. So you just have to go back and check and make sure that everything is okay. So here, again, let's check plots. So check the spelling, make sure they are the same. Okay, perfect. Now we have everything we need, so we can exit and save the changes. All right, let's rerun Circos again. So I'll say Circos-conf and I'll say Circos.conf. I'll run it, and then I should expect a new plot to be generated. All right, so I'll just wait for everything to get done for me. So it should be done very soon. So let's see. Okay, yeah, it has been done. So we can take a look at the file. So let's check it out. Nice. So you can see it here. So let's open it, and then we see that everything has been done nicely for us. Okay, so we have it here. Now with GC Skew, all right, let's take a look at the file. With GC Skew, we have negative values and we have positive values. So it would be good if we can distinguish or separate those values. Okay, here everything is orange, but some are positive, some are negative. So we can give colors based on that as well. So what I want us to do is to change the color for the positive values to green. So that means we have to add a rule. So I'll use this opportunity to show you how to add rules in Circos. Right. So let's go back to the terminal. Let's clear the screen. Let's ls, and then let's edit the circos.conf file again. And then let's scroll down to the plot section. The plot section here. Okay, this block, the subplot here, and let's add a rule. Okay, so here you add a rule. So we say rules, then we add rules. This block, that's a block. Okay, and then in it you add one rule. So rule. These things you have to do it over and over, and then you get used to it. So the rule that we are specifying is this. You say condition equals var value greater than 0. So all values greater than 0, color should be green. So color equals green. So this is the rule. It's very simple and straightforward. Okay, so this is it. All right. So once we are done with this, we need to make sure that the blocks are okay. So everything is fine. So you can exit and save changes. And then we can rerun Circos. I'll say circos.conf. So let's execute this command. Nice. So now everything has been done. So we are good to go. All right. So now let's see how it goes. So this should be done very soon. Okay, I think it's even done now. Yes, it's done. So you can come back and then view and open it. So now you can see some changes. Okay, so now we see that what we have orange, we have green. So now at least we are able to distinguish between positive and then negative values. Okay, so that's how we do it. Okay, now let's add this. We have our Circos plot here, but we can also change some stuff. For example, thickness, we can change it, and even the scale, we can also add it. All right, take a look at this one here. We added some scales. Okay, so 1 MB, 2 MB, 3 MB, just a division. So we can also add that. So for that one, you need what you call the ticks. All right, so for those who want that also, let me just put it. The downlink for this as well as the tick configuration file are available. So check the description, you find a link to get them. So let me just show you how that's also done. So the tick file is here. I've also prepared it already. So you can just download using the link that is in the description box. So open it and you find some information here. Right, so that's it. So the tick, this is how it is. So all that you have to do is to open our circos.conf file. Let me just do it here rather. And then after the ideogram line, add this. Include ticks.conf. That is if you have downloaded the ticks configuration file. And then edit and save changes. All right, but also make sure that the file is there, and then just rerun Circos again. Once you do it, then Circos will factor in that information and then give you a new plot. Okay, so now we are trying to improve it. So what we are going to see is this new figure. Okay, so we can open it and check. Now we see that it's here. It's also very, very nice and lovely. Okay, so this is now very, very cool. Okay, so we have it like this. All right. So with sequence data, there's lots of information that you can get, but then the challenge that we face is how to present it in a way that will allow us to compare, do comparison, and also identify patterns. And this is where Circos comes in. That is one of the things that we have done here. Okay, so this is one of the things you can do with Circos. It's very, very good. So I will encourage you to check it out. Okay, so this is it for this tutorial. And so what I will encourage you is to check this playlist here. You'll find more tutorials on Circos.